Hello, my lovely warriors. Time to stress yourself or de-stress yourself. Well, let's de-stress. And let's not take any strain, let's not take any stress, because today's chapter is all about stress and strain, and we are going to revise, we are going to do a quick revision of this important 11th standard topic for all the 11th to 12th moving students. But if you are a 12th standard or a dropper student, please feel free to watch it, because this is a one-shot problem solving and revision session. And Rupesh is wishing happy April Fool's Day to everyone. I'm not sure what is there to be happy about it, and I'm not sure if you should wish each and every day. Like, I've seen people wishing happy Women's Day or happy Men's Day. I'm not sure what exactly you are supposed to do unless you do something about it and you create some kind of awareness, or you do something about that. I'm not sure what exactly you should do during happy April Fool's Day. You can wish happy birthday, happy new year, but I don't know. Hi Nishi, hi Hema, hi Jia, hi Yashika, Vandana, Mergu. Welcome Rupesh, welcome Ramya, nice to see all of you. Can I start class 12 portion? Yes, please start. The April Fool's Day is considered to be the best day to start your 12th standard preparation. Yes. Else, if you start it on April 2nd, then most likely you will end up being a fool. Okay, so the 1st of April is a very good day. And guys, those of you who do not know me, my name is Shreyas and I'm the physics master teacher. And here I am, on JEE Enthuse, the dedicated English medium channel for all the aspirants, who are preparing for all the competitive examinations. So many of my students are in the top-notch IITs, top-notch branches, and I'm really proud about it. And I show this to you because I really want you to be one of these, one of these achievements, one of these pride moments that I have. Okay, so let's get started, and thank you all my fans, thank you all the students out here. PG Wolf, welcome. And let's begin. Yep, are you guys ready? Yep, so let's begin. Yes Ramya, I'll be doing a thermo revision also in the days to come. Definitely Ramya. Okay, so hi Arun, welcome. Hi Shivaji, I hope you guys have liked and subscribed. So let's do a quick revision of this topic. Very simple dimple, easy pimple, chapter it is. So let me tell you what and all is there in this particular chapter. Very easy way of remembering things. First of all, I'm going to divide my board into 3 sections, and I'm going to draw a few things so that you analyze and note it down. Okay, so there you go, something like this, and yep, over here. So in this chapter, you basically study deformations, elongations, compressions, etc. When you push, pull, and pressurize things, it will change its shape, size. That's what you study. But these deformations can be classified into 3 categories so that you can analyze all kinds of deformation. What are the different deformations that you can analyze? Well, the first one is longitudinal. You pull or push it, strain it, by pulling it, give it tension or give it compression. So that is longitudinal. So this one over here is longitudinal deformation. The second one is you slide 2 things, or basically you shear, you move one surface relative to the other. That is called as your shear deformation. And the third one is when you expand or compress something. So that is your volumetric deformation. Volumetric deformation or bulk deformation. Volumetric or bulk deformation. Everybody clear? Very good. Yes, Hema, I'll tell you, there is a beautiful playlist for oscillations and waves, Hema. In this channel, in this playlist, you will see there is a beautiful playlist called as the Nurture playlist. Just watch that playlist. Towards the end, you will see separate, all the lectures for waves and all the lectures for oscillations. Watch it, trust me, within few days, you will be a master in waves and oscillations. That's something I can tell you. Yep. So, good evening, everyone. Yes, solids are also of 2 types. What are the 2 types of solids? Come on, let me know. So I give usually simple examples for this. One is the tail of a dog. Have you seen the tail of a dog? Yeah, how is it? Yeah, the tail, this is, let's say, a dog. Okay. Yep, so this is our dog. So this is the tail. Okay, so have you seen the tail of a dog? It's curved, right? Have you tried to ever straighten it? Have you ever tried to straighten it? If you try to straighten it, it again comes back. If you take iron and if you put it under the iron box, and then if you try to iron the tail, guys, please don't do that. I was just kidding. Okay. Even if you try to basically make it flat, it will not become flat. It will come back to its original, curvature. So that is called as elastic behavior. It's elastic. You bend it, it comes back. You bend it, it comes back. You deform it, it comes back. That's elastic. And the second type is plastic behavior. Plastic behavior may be like your dough or clay or chewing gum. You pull it, stretch it, push it, deform it, it stays there as it is. Right? So that's how it is. So things which deform permanently plastic, things which come back, they are elastic in nature. Now, in longitudinal, shear and volumetric, remember certain formulas. First is your stress. So this is your longitudinal stress. Then here you have your shear stress. And here you have your bulk stress. You have your bulk stress. Similarly, here you have your longitudinal strain. Here you have your shear strain. And here you have your volumetric or bulk strain, whatever you want to call it. Based on these two things, you have certain constants which decide the properties of the material, how strong or how stiff or how easy it is to deform it. So those properties are called as the modulus of elasticity. For longitudinal, it is called as Young's modulus. For shear, it is called as shear modulus or rigidity modulus, symbol is G. And for bulk modulus, it is B. Now, what is Young's modulus? Young's modulus is sigma by epsilon, but sigma of longitudinal upon epsilon of longitudinal. If you are wondering what is this sigma and epsilon naught, this is longitudinal stress, and longitudinal stress is force divided by area, the force which you apply upon the area, this area. The force by area is the stress. The longitudinal strain is how much is the change in length upon the original length. If you pull it, there is some change in length upon the original length is the longitudinal strain. Very good. Similarly, in shear, the shear stress is nothing but how much force you use to slide it, to shear it. So force upon the area, but that force has to be parallel to an area. The strain which is there, that comes out to be how much is the tan of theta, where theta is the angle by which your surfaces slide. It's the surface was here, it slides here, so you have slided by some angle theta, so that is tan theta, which also becomes x by h. X happens to be the displacement which it has moved, and h is the separation between the two layers. And rigidity modulus is again sigma by epsilon. This is obviously shear stress, this is obviously shear strain. That's how it is. And in case of volumetric or bulk deformations, the bulk stress happens to be the change in the pressure. So when you compress or expand it, the change in the pressure is your bulk stress, and the bulk strain is change in volume upon original volume. Change in the volume upon original volume, and bulk modulus is the sigma bulk divided by the epsilon of that volumetric strain. That's it. Hello Kavi, no, you're not late. Yep. So these are the formulas which you should know. You should know the comparison. You can see very, very similar formulas. Always modulus is stress by strain, stress by strain, stress by strain. Stress is force by area, force by area, force by area, but this is for, volumetric or bulk deformations, that is changes in the pressure. Strain is always change in length upon original length, change in length upon original length, but here it is how much it moved per unit distance between the layers. And here it is change in volume upon original volume. That's it. Good evening, Saja. Good evening, everyone. Yep. Yes, Kusuma, there are a lot of things which we have planned. Already we are doing some mock tests, and we'll be probably also doing some important chapters revision for JEE 2022. Also the Dynamite series, I'll be putting up a video tomorrow where I'll be discussing one important problem almost every day. Okay, cool. The next important thing which you should know in this chapter is the energy which is stored when you stretch or compress it. So that is called as the elastic potential energy. So the elastic potential energy is given by half stress into strain into volume. Very, very important formula. The energy stored in any object which has been stretched or compressed is half stress into strain into volume. Also, whenever you take a body, okay, and you expand it or compress it, it extends by some amount because you have applied some force. This is very similar to a spring which is at natural length and you have extended it by applying some force. So when you pull an elastic body, it behaves very similar to a spring, and because it behaves in the manner of a spring, that law which relates the force and the displacement is also called as the Hooke's law. So when forces are proportional to x, it is that law which is obeyed is called as the Hooke's law. And just like you write F is equal to kx, here the equivalent spring constant for any body, is YA by L. And if you use this formula, you can also write force is equal to K equivalent into X. So this is the equivalent spring constant whenever you want to convert any body into a spring. Keep this in mind. So what's the difference between stress and pressure? Suchi Mama, see, stress at the end of the day is force per unit area, but stress can be different in different directions. Like when I pull something, okay, I'm applying stress in the, let's say, x direction, but the same force per unit area might not be there in the y or in the x direction. Pressure, on the other hand, is used for liquids or gases, not for solids. You never talk about pressure of a solid, you always talk about pressure in a liquid or gas, because the force per unit area in all the directions is same. So that quantity, that force per unit area, or the intensity of the force in case of liquids or gases, which is similar in all the directions, that is called as pressure. But in case of solids, it could be different. That's why you use a different term called as stress. Okay. Yep. Let's move to another concept. And yep. So these are the important things which you should know, guys. And one more thing over here. I'm so sorry. Today my AC is not working because there is no current. On my UPS only, the lights will work and probably my studio will work basic, but AC will not work. So I might sweat a lot, but that's okay. I have to conduct this class, guys. Now the next thing is the thermal stress. The thermal stress formula. Just one second. The thermal stress. So whenever you take a body and you hold it between two strong or two rigid walls and you heat it, you will see the body will develop some stress because it wants to expand, but it can't because of the rigid walls or the strong supports which are there towards the end. So the thermal stress is given by Y alpha delta T. What is alpha? Alpha is your coefficient of linear expansion, Y is your Young's modulus, sigma is your stress, delta T is your change in temperature. Yep, I hope this is clear. Last thing which is also important in this entire unit is the stress versus strain graph. You should know each and everything about the stress and strain graph. When you apply stress, the strain, the elongation increases, and it is proportional till a certain point called as the elastic limit. Proportional limit. It is directly proportional to the strain till a point called as the proportional limit. But after point A, when you increase the stress, the strain increases in a non-linear fashion. So this is the non-linear zone, but still it remains elastic, meaning if you relieve the stress, if you remove the stress, the body will come back to point O. So it behaves elastically till point B. So that point B is the elastic limit. It's also called as the yield point. So yield point is generally the point till which the body remains elastic in nature. After that, if you apply any stress, the body does not come back to point O, it gets deformed. So that is called as the plastic zone. So you pull it so hard that when you leave it, it does not come back. It's deformed. That's the plastic behavior. And if you stretch it hard enough at that point D, that's the maximum capacity, maximum load. At that point, it just breaks, and at this D to E is almost like instantaneous. The moment you apply any stress more than D, it immediately reaches here and it breaks at that point E. So very, very important. Yep. And one more thing which you should also know is that the area under this graph, gives you the potential energy which is stored per unit volume, meaning it will be in joules per meter cube. So when you stretch something, all right, till some point, and if you calculate that area gives you how much energy is stored in that body per unit volume. Keep this in mind. All right, fair enough. So let's start with some questions. I hope you guys have revised and brushed up all the important concepts. So we have brushed up all the major formulas of this chapter, the stress strain modulus, also the potential energy formulas, also the spring equivalent, thermal stress, and the stress strain graphs and their other important aspects of it. Okay, now the entire notes along with the PDF, everything, the solutions, everything will be available in the Telegram channel. So if you have not yet joined, make sure you join it ASAP, because all important updates, PDFs, everything comes on the Telegram channel. So let's start with the first question. Okay, let's start. GSK mains is not postponed further. It was just shifted by 1 week. That's it. After that, there are no new announcements. Hi, Anam. Welcome. Anam. Anam. Yes, I am guessing that's the correct pronunciation. How is shear modulus related to viscosity? Suchi, viscosity is also in a way kind of shear only, because when layers of liquid flow over each other, it's nothing but they are sliding over each other. So it's in a way related to shear. But the only difference is when we talk about viscosity, instead of using the term called as strain, you use a term called as strain velocity, because each layer is moving with certain velocity with respect to the other layer. So we define strain velocity instead of strain, and the modulus which comes out is no longer rigidity or shear modulus. It is now called as viscosity or coefficient of viscosity. Yes, Kavi, definitely. It is there, right? Anyways, 11th standard portions are there for your JEE 2022. Okay. So, what does the area of stress strain curve represent? Lavisha, like I mentioned, it represents the energy stored per unit volume. The energy stored, I just mentioned it. Right over here. Yeah. Energy stored per unit volume. That's what it represents. Yeah, that's something which you should know. Okay. So, I hope your doubts are cleared. Hi Siddharth, hello, welcome Bachalog. Hi Sunita, welcome. Oh my god, Anam, I hope you had a great birthday, and I hope I will get the cake whenever I meet you. Yep. What is the fracture point? Fracture point is the point where it actually breaks. That's it. You have applied enough stress, the maximum load has been applied. That's it. Any further increase causes it to break, and the point where you can no longer plot that stress strain graph, that's your fracture point. Yeah. So let's see how many of you can solve this question. An aluminium rod has a breaking strain of this much percentage. The minimum sectional area of the rod in order to support a load of this many newtons is. So first try to visualize the situation. You have a rod. Okay. You are applying some force. The Young's modulus is given. Also, you have to support this much newtons of load. The question is, what should be the area? Think, if you are applying some force and producing this much strain, then the force, the stress, the strains all are related by a simple equation, which is nothing but Young's modulus is stress by strain, and stress is force per unit area, strain is nothing but change in length upon original length. Now I think we need to find out the area over here. We need to find out the area, and strain percentage is given, so I don't need x by L. I will just keep it as epsilon only. So if you take area on the top, it will become F by YE. F by YE. Now let's see if I know all these quantities and start substituting the values over here. The force is given to be 10 to the power 4 Newton. Young's modulus is 7 into 10 to the power 9, and epsilon is in percentage. So if epsilon, the strain, is 0.2%, that means if you remove the percent, it will be 0.2 divided by 100, which is nothing but 2 into 10 to the power minus 3. So that is the value of the strain. How much is the change in length per unit length? So that is very small, which is fairly good value. Anyways, now 2 into 10 to the power minus 3 will be put over here, and 7 2s are 14, so 1 by 14 into 10 to the power. Here you have 4, and 4 plus 3 will become 7. 7 minus 9 will become minus 2. And 1 by 14, I think the answer, just check this out, 100, right? So 14 7s are, so 7 point, then 2, then 1. So this will be into 10 to the power minus 2 and into 10 to the power minus 2. So just check this out. Is it coming out 7.1 into 10 to the power minus 4? Just check this out. Is it coming out 7.1 into 10 to the power minus 4? Yes, that's the correct answer, guys. That is correct. Yep, very good, very good. Yep, excellent. So, weightage of the chapter Kusuma, almost like one question will come, most likely. Okay, or indirectly it can come as a combination with maybe thermodynamics or thermal physics, or it can come in combination with Newton's laws. It could come as a combination with sound and waves, very much possible. Okay, so what will happen if you remove the stress in the plastic region? Akshar, when you remove the stress in the plastic region, then it will no longer come at this point. So if you remove the stress here, it will come at this point. So it will get deformed. That is called as permanent set. So it sets permanently, that means it has been deformed. That means there is no stress, still there is some deformation. So how is that possible? That's only possible if it has deformed permanently. Alright, bacha, let's move on to the next question coming up on your screen. Okay, here we go. Very good. What will okay. So hello Hari Ventus. Okay, I will definitely consider buying new pajamas, definitely. I know, top secret. So when will JEE Droppers batch start for 2023? It will take some time. At least let the mains get over. The thing is, we have not started because we are really hopeful on you, and there are 2 attempts. In fact, we have crash courses so that you can actually crack the JEE irrespective of your preparation level in this year only. We want you to get at least some decent percentile, decent college in this year. If it doesn't happen, then we'll talk about it, but don't give up very soon. It's not the time to give up. Fight harder. All right. So hi Prajeen, welcome. I'm very good. I hope you two are doing well. It started raining outside in Bangalore, and Bangalore, the moment it starts raining, the first thing they do is cut the electricity. And it's raining outside, and even it's raining over here because I'm sweating. Yeah, my AC is not working because there's no current, and I just can use my UPS for the lights and this digital board. All right, so let's talk about it. Okay, so Ketav, for next year you don't have to join Droppers batch, you have to join the regular batch, that's it. Then yes, but if you want to join the Dropper batch only exclusively, then wait for a few months, then it will start. An iron bar of length this much, cross-sectional is given area, the force is also given. The question is, which of the following statement is correct? Okay, elongation related options are there. So I think I will start with this result. Force, sorry, not force, my bad. Young's modulus, let's start with this. Young's modulus is stress by strain. Stress is force by area, and strain is X by L. So shift these terms. So I will get X is equal to F, area comes below, length goes on the top, Young's modulus comes over here. So the elongation is inversely proportional to length. Obviously this is wrong. In fact, elongation is directly proportional to the length. You can see that. Elongation is directly proportional to the area. No, it is inversely proportional to the area. So B option is also wrong. Next, elongation is inversely proportional to area. Yes, this is correct. Lastly, elongation is directly proportional to Young's modulus. No, it is inversely proportional to Young's modulus. So option C should be correct. Yep, that is true. We got it. Very good, Rupesh. Very good, Hema. Excellent day. The Prajin, like I had mentioned before also, the price of the fusion batch would have now changed to 9,000 or 10,000 rupees. Remember, the last date for the offer was 31st March until midnight. Now, since we are past that date, the fusion batch enrollments are still open. You can still join my 12th standard batch where I am teaching in English medium, the entire long-term batch with 11th standard revision, test series, assignments, tattva, everything. But probably the course price will no longer be 8,000, it will be 9,000 or 10,000. So probably you would have lost that 1,000 discount, but that's okay. I mean, in the long run, it's going to work out because you're going to save lakhs of rupees for coaching and lakhs of rupees of college fees if you get a good college. All right. So let's move on to the next question. There is a wire which elongates by L millimeter when a load of W is hung from it. If the wire goes over a pulley and two weights W each are hung on the two ends, then what will be the new elongation? Let's see. Kusuma, you can leave a comment after the video ends. I will definitely reply you with a link where you yourself can check what is your expected cutoff for every branch or any NIT. Don't worry. So there is a pulley. You have hung two weights W each. The question is, what is the elongation? In this case, in the first case, there was the same wire and you had attached W weight. The elongation was L. So if in this case the elongation was L, the same wire, if you take it and put two weights over this pulley, then what will be the total elongation of the wire? Some of you are saying C option, some of you are saying something else. Come on, think about it. Is it A, L? Is it B, 2L? Is it C, 0? Or is it half? Come on. Siddharth, I will not be exactly conducting the same kind of long-term batch for 12th standard because I have already done in Pathfinder series, the entire 12th standard portion is done. So I won't be conducting a long-term batch for 12th standard on YouTube, but I will be doing problem solving, advanced questions, one-shots, those kind of things. But if you want a regular batch, please make sure that you can watch either the Pathfinder or you have the best option in a systematic way, the fusion batch. Good evening, Blessy. Nice to see you. All right. So guys, a lot of you are saying 0. Well, I'll tell you what, in this situation, in the first case, the elongation was happening because of the weight and the tension in the wire was basically the weight itself. The tension in the wire was the weight and this tension was causing stress. This stress was causing the elongation. This stress was causing the elongation. Now, in this situation, if I ask you, what is the tension in the string? What is the tension in the string? The answer will be, it will still be equal to W only. Reason? If you look at the free body diagram, W and tension will be equal to W. That's it. So if tension is same, stress will be same, and if stress is same, the elongation will be still the same and it will be L. Hence option A will be correct. Many students forget one simple concept that when you have a string and you support it at this point and you pull it with some force, the tension will be equal to the pulling force. Remember, when you are pulling this point, you are also indirectly holding it with the same pull from the top. Do not forget, it's not just that you are pulling it from one side, there is a supporting force from the other side. So actually you are applying two forces simultaneously. So when you bend it and put it over the pulley, it's still the same thing. You can just open this up and see it's the same string, same force, same pull from both sides. Hence the answer is A, which is L. Lot of students make a mistake in this. It is not 0, it is not twice L because there are two weights. Get this in your head. Convince yourself for this problem. This looks like a easy, but it can mess up your score. You can get negative marks because of this conceptual question. Okay? It's a very, very critical question. I've seen so many students, so many, teachers also making this mistake. Very, very critical question. All right, moving on to the next one coming up on your screen. Happens, Rupesh. That's the reason why I'm conducting this. Hello, very good, Jia. Very good. Very good. Okay, Akshar, I hope you realized it. Very good. Kamla, I think you would have also realized your mistake by now. All right. The extension in a string obeying Hooke's law is X. Extension is X. Speed of sound is V. If you now extend the string's extension to 1.5 times the previous one, what do you think the speed of sound is? Is there a formula for speed of sound? Yeah, the speed of sound formula is root of tension by, mass per unit length. How is tension related to the extension? By Hooke's law. So according to Hooke's law, tension is equal to K into X. So substitute that here. Therefore, I'll get V is equal to root of K X by mu. This is the first time when the extension was X, speed was V. Now, when you want to find the new speed, remember K is same, mu is same, but the extension is no longer X, it is 1.5 times of X. So if you notice, I can just take root 1.5 outside and the rest is as it is, Kx divided by mu, which I know is nothing but V. So I can just replace that with V and rest of the things I will just write it as it is. So V1 is root of 1.5 times of V. Now what is root of 1.5? You don't have to sit and calculate. Obviously it will be more than 1. So B option is wrong. It can't be D also because it is less than 1. So out of C and A, think which option will you choose? Obviously 1.5, how can root of 1.5 be root again 1.5? Doesn't make sense. Anyways, 1.5 square happens to be 2.25. So obviously this is wrong. This has to be correct because you can think this way. If you ignore the second decimal, 1.2 square is 1.44, which is very close to 1.5. So hence it has to be option A. That's how you can calculate in the exam by looking at the options. Is that okay, guys? So option A is correct. Moving on to the next one. Abhishek, nice to see you too. I hope your studies are going well. Is there two Hooke's laws? No, there is only one Hooke's law. Okay. Yeah. If we keep JEE for teachers, will they be able to crack? I doubt, because it's not about the knowledge of the subject. The problem is, like say for example, I'm a physics teacher or somebody else is a maths teacher or chemistry teacher. They have very good knowledge in that subject, but most of them would have forgotten the other subjects, to be honest. Okay, because we are not in touch with all the subjects. We would know basic things, but obviously it's been more than 10-12 years. Okay, so obviously you cannot expect all the teachers to remember all the 3 subjects. So very likely that most of the teachers may not be able to crack JEE if they write it now, except for their own subject. Yeah. So next question, the pressure of a medium is changed from this to this. The change in the volume is 10%. Temperature is constant. The compressibility of the medium. Compressibility. Let's try to solve this now. So what is compressibility? Compressibility is inverse of bulk modulus. It's reciprocal of bulk modulus. So can I find bulk modulus? I think so. Bulk modulus is the change in the pressure upon the bulk strain. So the bulk strain will come over here. And compressibility is 1 by bulk modulus. So it will be nothing but the bulk strain divided by the change in the pressure. Now it's just a matter of substitution. So compressibility will be bulk strain. Is the strain given? Yes. The change in the volume is expressed in percentage. If it is 10%, then the bulk strain is 0.1. 0.1 fraction is 10%. 1/10 is 10%, correct? Okay. So this will be nothing but 0.1. Change in the pressure. Change in the pressure, you can see 1.01 and 1.160. Just check this out. This and this. From these two, you will get the value of delta P, which will be 1.160 minus 1.010. Yep. So what will be the answer? Just check this out. So this will be 0.150. So it will be nothing but 0.150 into 10 to the power 5 pascals. So just put over here 0.15 into 10 to the power 5 pascals. So shift the decimal by 1 unit. You will get this as 1 by 1.5. Take 10 to the power 5 on the top, so it will become 10 to the power minus 5. 1.5 is 3 by 2, so it will just become 2 by 3 into 10 to the power minus 5. But options are in decimals, so 2 by 3 is 0.66 into 10 to the power minus 5. So which is nothing but 6.6 into 10 to the power minus 6. 6.6 into 10 to the power minus 6 is option B, guys. Just check this out. Not option A, option B should be correct. Why is it Pascal inverse? Because it is 1 by bulk modulus. So remember, bulk modulus has a unit of Pascal. 1 by bulk modulus will be Pascal inverse. So that's why you have Pascal inverse compressibility. Yep, that's the correct answer. Very good. Hello Ankit, long time bacha. I hope you are doing well. Moving on to the next question. So ready? We'll be starting one shots problem solving series for 12th standard very soon. But remember, meanwhile, the Pathfinder series is still available. So I won't be doing any long-term batches as such for 12th standard or even 11th standard, because my entire lectures are there for you guys, you know, in the playlist. But what I'll be doing is something special, advanced problems, one shots, shortcut tricks, those kind of things I'll be doing for each and every chapter, because no point repeating the same thing. Instead, you can watch it recorded, right? I will like to utilize my time for doing something better and good for you. Cool. Yes. Bulk is not Newton. No. Bulk is Newton per meter square. Hello Sania, welcome bacha. Please give lots and lots of mock tests. Keep it up bacha. Okay. So what about this? Stress strain graph is given. Yield point, breaking point and elastic limit are respectively. Come on, you can do this. Hi Rose, welcome. How do you do this question? So the first point is where the stress is proportional to the strain. So that is your proportional limit. This is your proportional limit. So first it will remain proportional. Next time it will, remember, you keep on extending it. It will reach a point till which it remains elastic, and after that it turns into plastic. So till this point it is basically going to be elastic. So that will be your yield point. And there is a maximum point till which you can bear the load. So that will be your breaking point. So this will be your breaking point. Yep, there you go. So A, B and C. So proportional limit is going to be, where is it? Breaking point, elastic limit and all of that. So I think we don't have proportional, we have elastic limit over here. Okay. So guys, I think there is some error in the problem. Yield point and elastic limit both are the same thing actually. Yield point and elastic limit both are the same thing. That's why I think, I made some error over there. This should have been actually proportional limit if I'm not wrong. This should have been proportional limit. Yep. I think there is an error in the question. Yes. Because yield point and elastic limit are the same thing. Yield point is that point till which it remains elastic in nature. So if it is proportional, so point A will be proportional, which will come in the end. Then yield point is going to be B. So B will come first and breaking point is C. So this will be B, this will be C and this will be A. So B, C, A should be correct if that's the way it has been mentioned. So this should have been actually proportional limit, guys. Yes. Okay. So C is also called as fracture point. No, after C where it actually breaks, that's where it is called as fracture point. Okay, Abhishek? All right. Yep. Great. Moving on to another question coming up on your screen. Two rods of identical dimensions with Young's modulus Y1 and Y2 are joined end to end. The equivalent Young's modulus of the composite rod is how much? Let's try to figure this out. Okay. So whenever you find such questions where rods are in series or in parallel, you should know the derivation of springs in series and parallel. If you know it, it is very easy, else you will find it difficult. Well, some of you might not have studied it. Don't worry, I will teach you. See, it's simple. First draw the two rods which are in series. Their lengths are same, and because they are in series, what happens is the force between the rods will also be the same. The same force gets transmitted when the rods are in series, because this rod will apply some force on the next rod, that rod will apply the same force on the previous one by Newton's third law. So the force gets transmitted from one rod to the other, so force is same. But what is not same is the extension. If this extends by x1, this will extend probably by x2, because their Young's modulus are different. Material is different. Now, when you combine it into one single rod whose new Young's modulus is y, total length is 2L, for the same force, what will be the extension? That extension will be equal to x1 plus x2. This rod extends by x1, this rod extends by x2. If both of them are here, the total extension will be x1 plus x2. So can I say x is equal to x1 plus x2? Agree or disagree? Everybody? Yes, this is important because this is easy. Next, what to do? Just see how can you replace x with the force and the lengths. Is there a generic formula? I think we can do that. Young's modulus is force by area upon change in length upon original length. Rearrange this. X will become force divided by area. Length goes on the top. Young's modulus comes over here. So x is FL by AY. So substitute it over here. So x will be equal to force, length will be 2L. Do not forget the length is 2L divided by A into equivalent y. X1 and x2. What will be x1 and x2? It will be force into individual length divided by A into y1, and this will be F into L and A y2. All the things will get cancelled. What will be remaining is 2 by y is equal to 1 by y1 plus 1 by y2. LCM, if it is taken, you will get y1 plus y2 divided by y1 y2. So that is 2 by y. So y will be equal to 2 times of y1 y2 divided by y1 plus y2. So that should be the answer, and I think option A is correct. Yes, it is. Very good, very good. Excellent. B, no, it is option A, bacha. Yes, Nandini, V-Fusion, is still available, but maybe not at the same discounted price, probably at 9,000 or 10,000. We can check it out later on. I will show it to you towards the end. Okay. I'm so glad, Rose, it's helping you. Very good, Hema. Yes, it is option A. This chapter, like I said, lol, it is important, but not high weightage. But if you get a question, I mean, you don't want to lose the marks. You can't afford losing marks in this chapter because it's easy. Okay, cool. Okay. All right, Sanya, no problem. One end of a uniform wire of length L and weight W is attached to a rigid point in the roof, and W1 is suspended from the lower end. If S is the cross section of the wire, the stress in the wire at a height of 3L by 4 from the lower end is. Let's solve this question. Okay, let's draw the diagram first. So there is a roof over here, there is this wire, and you have put a weight below it. The weight below is W1, and the weight of the entire wire is W for some length L, let's say. The question is, what is the stress? What is the stress at 3L by 4 from the lower end? So 3L by 4 will be somewhere over here. So this is your 3L by 4. At this point, the question is, what is the stress? In order to find the stress, you need to find the tension at that point, because stress is force by area. So we need to figure out what is the tension force over here. What is the tension force over here? Now, I'll give you a simple logic to understand what should be the tension. If you're here, the tension at that point will have to bear, it will have to hold whatever is there below it. Whatever mass is there below it, it has to hold it, because the string and the weight which is suspended, it will try to fall down. You have to hold it. So the tension force will be equal to the weight below the point. Weight below the point. So now, can you guess what is the weight below this point? Well, I think it's simple. First is W1 plus the weight of the string plus the weight of the string. What is the weight of the string? It will not be complete W because W is for length L. For 3/4 of the length, the weight will also be 3W by 4. The weight will also be 3W by 4. Correct, guys? Understood? Very good. So now you just need to substitute it here. So it will be nothing but W1 plus 3W by 4 divided by area. Area is given to be, I think, S. Yes, if S is the area of cross section, so this is S, so that is your stress. So that should be option C, guys. Option C, correct. You can see that right over here. So the catch is to find out what is the weight of the string here, also to realize that the tension will only balance the weight which is below it. As you go up, it will have to support more and more weight below it, so it will be more and more. As you go here, tension will be less. As you go on the top, the tension will increase. That's what will happen. Thank you so much for all the likes and the shares and the subscribe, guys. Very good, Hema. Very good, Akshar. Excellent. So, Vignesh, Nurture series is for 11th. For 12th, it is called as Pathfinder Vignesh S. And the 12th standard long-term batch has been already put up in the playlist. I'll just show it to you. I'll just show you where it is. I'll just show you. It's all there. Instead, what I will be doing is I'll be doing problem solving, one-shots, shortcuts, tricks, and guidance sessions for all of you for 12th standard. No point repeating the same thing again and again. Okay. Why 3L by 4, Subhash? It was given in the question. Look over here, 3L by 4. So that's the reason why we had to take 3L by 4, Subhash. Okay. Hema, I think I just did a quick revision for waves just some days back. Just watch the lecture. It should be there in the playlist or in the past videos. Yes, Nishi, that should be good enough. Yes, it's good enough. But you, as an additional input, you can also solve HC Verma. Okay. Yes, Waves CDCM, I'll be doing series for 10th moving 11th. Yes, we'll be doing some bridge courses. We'll be helping you out, understand what books to follow, what should be the methodology, how should you study, everything. We'll be doing that. Okay. When was Vectors quiz held on this channel? Long time back, Harsha. Just go to the Nurture playlist. Go on the first few videos. Probably you will find it in the initial stages only. Yes, let's move on. Okay, can we just concentrate on 12th more, because I felt that it was easy from the 11th standard and few chapters are enough. Yes, Rose, in fact you have to concentrate 80% to 90% on 12th, the current syllabus, and probably 10 to 20% on your previous year or your backlogs or your revision of 11th standard. That's usually the percentage. Okay, let's see if you can solve this question. NCERT is not necessary, Sharon, NR. It's not necessary for physics. For all the chapters, only for few chapters you need it, which are like, mains exclusive. Example, optical instruments, diffraction, communication systems, semiconductors. Only for those few chapters you will need it. Apart from that, HC Verma, Tattva, previous year question, more than enough. A uniform cylinder rod of length L, radius R is made of a material of Young's modulus Y. The rod is heated and then also it is subjected to a compressional force so that the length remains unchanged. So first of all, visualize what is happening. This is your rod. It wants to expand because of heat, but you are not allowing it to expand because you are holding it by applying some force, compressive force from both sides. So you are applying some compressive force. So you are not allowing it to expand. Hence there will be some thermal stress. The question is, what is the material's coefficient of volume expansion? I think it's a question on thermal stress. So we all know the formula for thermal stress, guys. What's the formula? Sigma thermal is Y alpha delta T. What is stress? Force by area. So force by area is Y alpha delta T. Now I think we need coefficient of volume expansion. So let's do one thing. Before that, area is pi r square. Y alpha. Okay, I know what is the relationship. It is nothing but gamma is 3 times of alpha. The coefficient of volume expansion is gamma. Alpha is coefficient of linear expansion. So alpha will be gamma by 3. So just put gamma divided by 3 and change in temperature is given to be T itself. So basically gamma will be equal to 3F will come on the top and pi r square will come below, and Young's modulus and temperature will also come below. So just check this out if option C is correct. Yes, option C is correct. It is. Very good. BM Sharma is not good for JEE Bacha. It's good for people who want to teach or who want to make some question bank, but for students it is not advisable. I never recommend Cengage for students because it is very complicated to understand which questions to solve, which questions to not solve. So please do not refer Cengage. Maybe for other subjects it works, but for physics please don't work. Which portion will cover most at JEE 11th or 12th? It will be equal, Subhash Dhoni. Almost 50% weightage is there. Yep. Hari, yes, you are very late, bacha. Hari, I conduct my classes usually at 7 o'clock in the evening. It starts 7 almost every day. And if you don't want to miss my class, first hit the subscribe and the bell icon. Number 2, join the Telegram channel so that you are actively notified on when the classes are. All right. Yes, Sanya. It is important question for JEE. I mean, you mean this question or in general all questions? Well, all these questions are definitely important for JEE, but this specific question, I'm not sure. So obviously nobody can guess what question will exactly come, but yes, this series of questions are important for cracking JEE so that I can cover all the aspects of this chapter, bacha. So Harsha, I feel that you should study from Tattva. Number 2, Arihant PYQ. Number 3, H.C. Verma. These 3 books are the most important books. Once you start preparing for advanced, then the 4th book will come, and that is I.E. Irodov. That's it, more than enough. Yes. Let's see how many of you can get this question now. Yes, Anya, all these questions are important for JEE. Yes, it is. Okay. So defects of vision class 12 boards में आएगा. Depends कौन से board में हो उसके हिसाब से a rock stack. Okay. So Rupesh, you will get the Tattva books if you join the Fusion batch or if you are a part of the Pro subscription. In Fusion batch we give the soft copy, but if you are in the Pro subscription, okay, then you get the hard copy. So in the Pro batches you get additional benefits like doubt solving and after the class and the Tattva hard copy and mentorship and all of that. But yes, if you're okay, I just want the lectures, I want the test series assignments and the soft copy, then go with the batch where I am teaching, which is the Fusion batch, and there you will get the Tattva soft copy as well. Okay, so let's defects of vision. I doubt itna important nahi hai a rock stack for boards. Basic aayega myopia and hypermetropia and all that, and that too for correction. I mean, not more than that. Okay, so the length of the material is L when the tension is F, XL when the tension is YF, then the natural length of the wire is. Let's assume that the natural length of the wire to be A, which is unknown. Just assume. The length of the wire is L when the tension is F. So using Hooke's law, where the force is some constant multiplied by the extension, I can write for the first case L when the force is F. So for the first case, that force is K into extension. Length is L, original length is A, so extension will be L minus A. See if you guys agree with this. Gia, coefficient of volume expansion for the previous one, I'll tell you, it's nothing but, you had that formula, change in volume is initial volume into gamma delta T. So these are material properties which tell you how much will the material expand when you heat it. So you have for length linear expansion, for area beta, which is areal expansion, and for volume expansion you have gamma, coefficient of volume expansion. Okay, so now F is equal to K into L minus A, which is the final length minus the original length, that gives you the extension. For the second case, when it is XL, the force is YF, So for the second case, YF will be equal to K into new length is XL. So XL minus A. So I know what to do now. I'm just going to divide. Just divide this with this. So YF by F will be equal to K by K. And here you will have XL minus A. And here you will have L minus A. FF KK will cancel. So take it on the other side. So Y into L minus A will be equal to XL minus A. So this will become YL minus YA is equal to XL minus A. Bring terms with A on one side. So it will become A minus YA is equal to XL minus YL. A is common, so it will become A into 1 minus Y. L is common into X minus Y. So therefore, A, which has to be found, will become L into X minus Y upon 1 minus Y. But I think everywhere it is Y minus 1. So it will be L, multiply numerator and denominator with minus 1. So it will become Y minus X upon Y minus 1. So is that option there? Yep, option B. It should be option B, guys. Yes. So what is the morning time of the session? On YouTube, we don't generally conduct morning classes because generally students are out for school or college or for some other reason. You know, generally I have seen that students attend very less in the morning. So usually we keep our classes in the evening, which is comfortable for most of the students. What is the name of the Telegram group? Harsha, the name of the Telegram group, you don't search for it because it's a private channel. You will have to go below, join it using the link only. So I'll show you where and all it is there. But before that, this is your homework question. I want you to solve this as homework and post the answers in the comment section. I want to see who all are able to solve this, and that too really quick, especially after the session. Now I'll show you all the important links. But before that, let me tell you that last year we had more than 1,500 advanced selections, BITS toppers, CT toppers, board toppers, all other exams, be it JEE Mains, any exam you take, there have been lots and lots of students who have cracked the exam via Vedantu. It's no longer a debate of offline versus online. It's in fact now, you know, with online has proven track records. Now you have to decide when you want to start your studies with Vedantu. Be it from YouTube, be it on our platform, be it through our app, be it through the website. Make sure you do not fall back behind, because there are lots and lots of advantages when you study online, and especially through Vedantu, because we have a new wave of learning and we have the best teachers in the country, and you can get those teachers right at the comfort of your home without having to travel anywhere, and you don't have to worry about missing classes, you don't have to worry about missing the notes, and you get the best analysis of your assignments and your test series. And for the JEE 2022 students who want to ace their preparation for JEE Advanced, who want to crack JEE Advanced, we have the special Ekalavya batch. The entrance test is on 3rd of April in the morning. There is a link in the description box. Make sure you enroll and join that Ekalavya test. It will be a good practice test. If you do well, you get yourself enrolled in Ekalavya batch. It's free of cost for all the students. Okay? Because I don't want you to wait till the end. Also, all my lectures are available, okay, which I have conducted on YouTube right over here in the playlist. A lot of students keep asking me, sir, I'm in 10th, I want to study 11th. I'm in 11th, I want to study 12th. I'm a dropper, I want to revise the lectures. So one thing is last minute revision series. You have 0 to Hero playlist where you can cover all the chapters in one shot. Another playlist which is very important is the Pathfinder. Do you see this? For Pathfinder Physics playlist, just click on this. Oops, sorry, I had to click on the playlist, guys. Yeah, so when you click on the playlist, you will see all the chapters are there, right from electrostatics, current electricity, EMI, modern physics, semiconductors, all the chapters are there. Similarly, if you notice, there is also full playlist for 11th standard, which is JEE class 11th, nurture playlist. Click on this. You will see the entire playlist right from units and dimensions, kinematics, rotation, waves, all the things are there over here. This is another important playlist just for all of you. Now, there are students who want to attend my lectures in the Vedantu platform. So for them, I have that option as well, Do you see this JEE 2023 English batch? Click on this. So click on this link. You can change to whichever batch you want to. So this is your 1 year 2023 batch where I will be teaching. I am teaching in this batch. The test series are there, assignments are there, notes are there, doubt solving in the class is there. Now, yes, oh, guess what? The price is still at 8,000 rupees. I think you should make full use of it. It was not supposed to be 8,000. It was supposed to be 9,000 or 10,000. I think it's a glitch or what, because the offer was only valid till yesterday. So if it's a glitch, make the full use of it and let your friends know that there is some bug, and make sure that you join it ASAP before it changes to 9,000 or 10,000. This discount is not supposed to be 2,000. Make use of it. Okay. So Telegram link is not opening. Okay, I'll tell you what you should do. So now if you go over here, do you see this is your Telegram link? So just click on this link. That's it. It will open. Now, if it doesn't work, there is a t.me over here. So that T, right? Replace it with Telegram, the word Telegram. Usually when you replace that alphabet T with the word Telegram, it will open and you will be able to join. That's what you can do. Okay, Harsha, I hope that works for you as well. So, is there any issue? I think, I'm not sure, Nirlan, but don't worry. Usually, even if there is an issue, it gets rectified within few minutes or half an hour or so. Don't worry. Okay, entrance mock link. Well, it should be, if it is not here. Okay, if you want to join the Ekalavya batch, guys, the link will be here. Do you see that? Ekalavya, your ticket to most, the best advanced course, available online. So it should be probably, oh my God, it is not here. Interesting. Okay, I will ask the backend team to put up the link, very soon. I'll ask them. Yeah, I will be teaching in the Vedantu Fusion JEE section. Yes, Nitin, I am teaching in the English batch. Yes. Okay. So, yep, I hope this is clear. Even the links no, Nilan, it will work. All the links will work. Okay, all the links will work. Whichever link you choose. So let's say you choose this link, it will work. This is your link for changing your display picture. It will work. See, Telegram link will work. Everything will work. You can see view in Telegram. Now this is Windows. If I had Android or iOS, then it will obviously redirect me to the Telegram app. Okay, the website link. Okay, I'm not sure, Nilan, if the website has some problem, but don't worry. Within few minutes or few hours, it will get corrected. Okay, thank you, Nitin, so much. Thank you, Bachalo. And I hope I have answered all your doubts and queries, and you had awesome fun in today's class. And take care, study well. I'll be seeing you again tomorrow. Have a great time, sleep well, and God bless you. And please study really hard. Hasta la vista. This was Captain Shreyas signing off.